Okay, this is everybody's favorite. Simplifying complex fractions. Going to use the LCD method. And here's a denominator, here's a denominator. LCD is going to be 5x. Multiply everything by 5. Each of these inner fractions by 5x. That's not a fraction, but we're going to multiply it anyways. Okay, so first up, these two, the x's will cancel out, and we get 5. And then this is just straight up multiplication. Down here, when we multiply these, 5's cancel out, and we get 2x squared. And then this is just straight multiplication there too. All right, so now we should factor as much as we can and see if we can cancel factors. If not, we have our answer. So here, 5 is definitely a GCF. We could say 1 minus 3x. And down here, the only things in common I see are x. So inside we're going to get 2x plus 5. You know what? I think we're done because here are the 4 factors. That's a factor, that's a factor, and none of them are the same. So that's got to be our answer. Another method, which I know a lot of you are going to try or are kind of like loyal to, is by doing 2 separate problems, this problem and that problem, and then doing keep, change, flip when you divide. So for to subtract these, you need a common denominator. So this one needs an x and that one needs an x. So you're getting 1 over x minus 3x over x. And that's going to be 1 minus 3x over x. Common denominator, just do the tops. This one will need a common denominator of 5, so we're going to call that 5 over 5. 2x over 5 minus 5 over 5 goes to 2x minus 5 over 5. Okay? This is the one we're going to keep. This is the one we're going to flip. 5 goes on top. 2x minus 5 goes on the bottom. Okay? And now when we multiply, it's like we have one giant fraction. But 5 goes on the outside of 1 minus 3x. And I'm not going to distribute because I'm going to have to factor anyways. And, well, I think we end up in the same place. I'm not going to distribute these because after I distribute, I'd have to factor to see if any of these are cancelable. So I'm just going to leave it like this, and I think this is our answer.